Hey there, Mustangs. Welcome back to another edition of No Hair, No Problem. Rosenwald here. We're working on chapter 5.2 notes. Chapter 5.2 is actually the exact same thing as 5.1. The difference is now you're going to be doing proofs where you actually are told what the problem itself equals. And so your job is to just prove that it actually does equal that. As we work through these, I'm going to work through 6 problems with you, and we're really just going to focus on some good strategies that we can implement to kind of work our way through each one of these problems, okay? If you get stuck, my recommendation is I would pause the video and I would maybe try to do a couple on your own just to see if you know what you're doing, and then kind of come back and check in with me to see that you actually do know what you're doing as you're working your way through these, okay? So let's get started on number one. Make sure you have your yellow cheat sheet with you so that you can actually follow along. Again, try something and just see what happens. And if it doesn't work, try something else and keep trying different things until eventually it works. And throw ideas out there. Remember, we listen but we don't judge. As you guys are working with your friends, we listen but we don't judge. All right. So let's start with the first one here, 5.2. Example number one. It says prove that this left side is equal to the right side. Now, this is what we call an algebraic identity because there's no trig involved, it's just algebra. And I am telling you that it is, in fact, true that this left side of the equation actually does equal the right side of this equation. So as we're working through this, there's a couple things that you're going to hear me mention. We got the LHS and we've got the RHS, okay? We've talked about this previously where the LHS stands for the left-hand side and the RHS stands for the right-hand side. One of the things you want to do when you're working through these problems is wherever it looks more complicated. So in this case, this problem right here looks much more complicated on the left side than it does on the right side. So let's take the left-hand side and slowly chip away at it to make it kind of narrow down or simplify back to that 2 that's on the right side, okay? So let me dive in here. First, let's talk about this left-hand side portion that has this x squared minus 1 on the top. I'm going to show you a common mistake that a lot of people make, and you'll get marked wrong if you do this, okay? People seem to think it's okay when they're doing these kind of problems to just take the square that's there and the x that's there and cross those off, and the ones that are there are going to cross those off. And you can't do that. I'll show you algebraically why you cannot cross off individual parts like this. If I had 10 plus 20 divided by 10 plus, I don't know, let's say 40, okay? You would think, oh, I could just cross these 10s off and this is going to be equal to a 1. And I could just cross the 20 and the 40 off to simplify to equal a half. So then this is going to be 1.5. That's what people think. Well, if you actually do the simplifying for this, we end up with 30 over 50. That's when you go adding straight across on here, which that reduces to 3/5. Okay, and these are not the same. So the rule to remember when you're doing fractions is if it's a binomial, you can't cross it off with another binomial unless the binomials are exactly the same. Well, we can, in this case, get these to be the same. Watch. X squared minus 1 is the difference of squares. So I can do x plus 1 and x minus 1, and that's going to be x minus 1 on the bottom there, which then tells me, well, I can cross off those, and we're left with just an x plus 1 for this left portion. Okay? Let's go ahead and simplify the right portion of this, so that x squared minus 1, which, again, is going to totally match up with what we just did. Same thing. We're going to have an x minus 1 and an x plus 1 over x plus 1. So those x plus 1s will cancel. And this is where you need to be very careful. This minus sign that's in front is going to be a problem for some people. You have to remember that that minus is going to get distributed to everything that comes after it. So if we distribute that minus to everything, we're going to have a minus x and we're going to have a plus 1. And we're saying it's supposed to be equal to 2 at the end of the day. Well, now I can go ahead and simplify. The x's will cancel out and we're left with a 2. That 2 is equal to the 2, which is what we started with. Okay? All right, let's move on to example number 2 here. So this kind of fits the exact same thing that I just said to you in the previous problem. When you're working on these, you always want to try to take the harder stuff and simplify down to the easier stuff. And one of the things that we should be looking for when we say more difficult versus easier or clues is how many terms we actually have. This right here is a binomial. The reason there's a binomial here is because of that minus sign that's in the middle. The minus sign says that we have one term minus another term. Versus when we look at this other one here, the operation that's in between is multiplication, which means that this is actually a monomial. versus a binomial. So if we ever have a binomial, it's easier to chip away at it and bring it together to get it be a monomial at the end of the day. So let's try working through this one, okay? When we look at this one, first thing we should notice here is that we have, now I'm going to leave this right-hand side alone. We're going to work along the left-hand side here to try to get it to match the right-hand side. When we look at this, I have a few things that I can look for. Like, do you notice how there's a cosecant here, but there's no cosecant over on the other side? Well, that tells me I can probably get rid of this cosecant, so let's try something. I can treat this sign as just an s, and for the other portion, that cosecant, that's really just 1 over s. Last time we worked with these, we said, well, we have two separate fractions, and because we have two separate fractions on the left-hand side, right here there's 2, but on the right-hand side there's only 1, it stands to say that I'm probably going to take these 2 and join them together to make them 1. So in order to do this, I need a common denominator. Well, if I put an s on here, that means that I have to put an s on the top as well. Now that my denominator is the same, I could merge these together, and we end up with an s squared minus 1 divided by s. So one of the common mistakes that people start to make, again, goes back to what we just did in the previous problem, is they go, all right, well, I'm just going to cross these off. And when I cross those off, they end up with an s minus a 1. Well, you can't do that. You cannot just cross off one thing, because the reality is that this s that's right here is part of the left side, and it's also part of the right side. So you can't just cross those off and say, bye-bye s's, okay? So where do we go from here? Well, one of our clues that we should look for, there's a cosine in here. I don't have a cosine on that left side. Where did that cosine come from? Well, this is one of our Pythagorean identities, that we know that c squared plus s squared is equal to 1. So if I want to get an s squared minus 1, I move this over, I get s squared minus 1. But to get it alone, I move the c squared over, and we get negative c squared. That's going to help us in this problem. That sine squared minus 1 that we have right here is the same thing as this sine squared minus 1. So let's go ahead and replace that. Now we're going to have a negative c squared over s. Okay, so we're getting there. We're close. Whenever you see two separate terms over on the right-hand side, but there's really one right here, it makes sense to go ahead and take those c's and split them up so we can actually work with those. If I break this up, I have a negative c, and then I have another c, and it's over this s like we have here. Think about what happens here. This s, or this c, matches up with this c right here, that cosine. And this c over s right here, believe it or not, matches up with that cotangent, because cosine divided by sine is, in fact, cotangent of x. And these are equal. And now that matches our right side. Okay? All right, let's go ahead and move on to our next question here. All right, number 3. Number 3, same exact premise. We're going to try to simplify this. Excuse me. And so when you look at this, we're looking for clues, again, to work through this. And we should see something. These are both monomials, okay? Those are both monomials, which means that my two portions that we have at the top should merge up. Because when I look at this up top, that plus sign makes these a binomial. You got one term right here plus another term right here. So those binomials are going to want to join up and become just one thing in the end of the day. So I'm telling you, one of your answers, or this combined, is equal to one of these answers. The question is, which one? So let's try to work to simplify this if we can, okay? We're going to start with 1 over secant of x plus 1, minus 1, plus 1 over secant of x plus 1. And when we look at our identities, we don't have secant of x minus 1, but here's what we do have. We do have secant squared minus 1. Since I have separate fractions, what if we worked on trying to get the fractions to join up by using the other denominator that's in the part of the problem? So if we use a secant of x minus 1 and secant of x plus 1, whatever I put on the bottom, I have to put on the top. So we get secant of x plus 1 here and secant of x minus 1 here. And now my denominators match up with each other. So now let's take the numerators and go ahead and throw these together. If we do that, we have secant of x plus 1 for the left part on the top. And on the right side, we have secant of x minus 1. But on the bottom, we have secant squared x minus 1. So where do we go from here? Well, we can take those ones that are in this problem and we can cross them off, and we now have 2 secant of x's. Okay, and for that denominator there, we have a identity. If you look carefully at your identities, you have that tangent squared of x plus secant squared of x, plus 1. Sorry, I wrote the wrong thing there. Plus 1 is equal to secant squared x. That's your Pythagorean. So if I move the 1 over here, we know that that's now going to be equal to tangent. So why don't I take that denominator there, that's secant squared x minus 1, and let's make it equal to tangent squared x. Okay? So where does that leave me? Well, if we look at the left side of the problem here, we've got a secant over here, which means the only thing that we're left with is a cosine. And then over here, we've got a cotangent, which means there has to be a sine involved, a couple of them actually. So remember I said when you're in doubt, one of the things that you can do is actually change things from sine and from secant and cosecant and tangent and cotangent. You could change those into sines and cosines so they're a little bit easier to work with, a little less confusing. Okay. So here's what we know if I was to go that direction. We have in this, it says 2 secant of x. Okay, that's what it currently says. And then we have a tangent on the bottom of my fraction here. Well, if we go back to our identities, 1 over tangent is the same as cotangent. So we have our cotangent squared x right here. Okay. Let's see if we can simplify a little bit further. We know that secant is the same as 1 over cosine of x. And we know the cotangent is the same as cosine squared x over sine squared x. So that means that I can take one of my cosines away from each of these, and what we're going to be left with is a 2 and then a 1 over sine squared x. Okay. And I'm sorry, we still have a cosine. Whoopsie doodle, I accidentally deleted that. So we still have just one of these cosines remaining here. I crossed off too many there. And so we still have a cosine of x remaining here. Okay. Well, let's kind of mishmash things so that they actually work together here to kind of fit in. You can see we're kind of working towards that first answer that's over there on the left side. Okay. That when we look at this, we're going to have a c over s. And then we're going to have a 1 over s. That's that c and s squared. And so what that means is that when we look at this, the cs is going to give me a cotangent of x. And the 1 over sine is going to give me a cosecant of x. And there we go. That matches up with what we were looking for. Okay? Oops. All right. So again, you can kind of see things unfolding. They kind of converge and work together here. All right. Let's go to example number 4. In example number 4, we are set up so that, and I'm going to tell you right now, this is one of the common things that people do, is they try to take this and cross multiply. And when we're doing a proof, you can't cross multiply. It's just a violation that you're not allowed to do. Okay? With a proof, you have to work with one side or the other, or you work with both sides, but you don't crisscross. Okay? So let's go ahead and take, for example 4, let's work with, it's up to you really how you want to do it, but I'm going to do the left-hand side. Okay. When I look at this, we have an s over 1 plus c. Now I want you to notice something, that on the right-hand side of the problem, we do have a 1 minus c. But I don't have that on the left-hand side. And because I don't have it on the left-hand side, it stands to say I need to put it on the left-hand side. Well, in order to do that, I can go ahead, because I'm allowed to do whatever I want, I can add in a 1 minus c on this left-hand side. And what ends up happening is we have on the top, we have an s minus an sc. Okay, actually, hang on, I'm not going to do that. Sorry, I meant to do just s times 1 minus c. And on the bottom, we end up with a 1 minus a c squared when I multiply that denominator out. Well, believe it or not, this is one of our Pythagorean identities, right? C squared plus s squared is equal to 1. So if I simplify this, we know that s squared is equal to 1 minus c squared. And so if I do a replacement here, we get s times 1 minus c divided by an s squared. Okay, one of my s's cancels, and we're going to be left with 1 minus c over s, which matches up with what we had on the right side there. Okay. All right, a couple more here. So on this one, this was one where it's like, ugh, I don't know. I mean, both sides look equally challenging, don't they? Neither side really looks that great for us. Okay, so what are we supposed to do? How do we get it to actually work and converge? Well, we just experiment with something, because the left-hand side might work, the right-hand side might work, or both sides might actually work, and trying to get them to converge on each other. Let's see what we can do here. We're just going to experiment. Okay. So when we look at this, I'm going to go ahead and try the left-hand side first. We have an identity that says that tangent squared is equal to secant squared x minus 1. So I'm going to change this to secant squared x minus 1. Okay. And on the bottom, we have 1 plus secant of x. All right. If we go ahead and factor out that top part there, because it's the difference of squares, we're going to have secant of x minus 1 times secant of x plus 1. And on the bottom, we're going to have 1 plus secant of x, which means that those secant of x plus 1s are going to cancel, and that's going to leave me with just secant of x minus 1. Now I'm going to kind of pause right there, but you could keep going if you wanted to. I'm just going to pause because I feel like something's off right here, because when I look at this, I've got a secant here, which has to do with cosines, but over on the right side, I still have a sine here. So something's not right. Let's see if I could try something. All right. What if I went on the right side and I said, well, we have an s squared over here, and we have a c plus c squared on this portion. Let's go ahead and take that sine squared and convert it over to what we know. We know that sine squared is the same as 1 minus c squared. And on the denominator, we have c times 1 plus c. Okay? So I can simplify that top part and make it 1 minus c and 1 plus c divided by c times 1 plus c. Okay? Well, now these c's cancel, the 1 plus c's cancel, and I'm left with 1 minus c over c, which, if I simplify this, I can actually break this up into 1 over c minus c over c. And 1 over cosine is the same as secant of x, and c over c is the same as 1. I was able to get both of these sides to converge. So this is one of those examples where I could do the left-hand side or the right-hand side, or I can do both sides and eventually get them to converge. That's a way of proving them as well. Okay? Now this last one is a bit of a doozy. It takes a little bit of thinking, and I would actually strongly recommend that you go ahead and try to do this first, and then come back and see if you can get the answer. Okay? This is one that's like higher level, like calculus stuff. All right? Going back to the strategy we said, the right-hand side on this looks much worse than this left-hand side. Now you can try to take this left-hand side and break it up to meet to the right-hand side. It's up to you. But I'm going to take the right-hand side on this case, and I'm going to try to simplify it. Okay? If I was to go ahead and simplify this, here's the way that I would approach it. I look at this as a trinomial, and that trinomial has way too high of a power of sign within it. So let's see if I can factor out something here. If I factor out s squared, I'm left with a 1 minus 2s squared plus s to the 4th times c. Okay? Now, a little clue in this problem is that I have c to the 5th power. So somewhere, somehow, some way, I need to come up with 4 more c's because I only have 1 c in this problem. So let's continue. This sine squared, if I rearrange this trinomial, that's going to say s to the 4th minus 2s squared plus 1 times c. That s to the 4th minus 2s squared plus 1, I can actually factor that. That would be s squared minus 1 times s squared minus 1 times c. All right, well, this leads to one of my Pythagorean identities, that we know that c squared plus s squared is equal to 1. If I make this minus 1 over here and this goes over here, that means that we're going to have s squared. That s squared minus 1 is going to turn into a negative c squared. That s squared minus 1 will turn into a negative c squared, and then a c. And we look, we have s to the second. The two negatives that are right here are going to turn into a positive, and then you count, we have, carefully, we have 2, 4, and 1 more c. We have a total of 5 c's. That now matches our left-hand side, okay? So I'm obviously experienced with these, and I have a key, quite frankly, to look at these, but I've been doing these for a while, so it just comes naturally to me. But what I would say is try things. Try and fail. Try something different. Talk to your group. See what ideas they have. Maybe the left-hand side would have been easier here. Maybe the right-hand side is easier. You don't know until you experiment, but just try something. And if you get completely stuck, just ask. Till then, till next time, you guys take care of each other. Be safe, be respectful, be responsible. Don't forget to like and subscribe to my channel, and have a wonderful day.